Welcome again, ladies and gents. Today what we're going to focus on is an expansion of the metric conversions that we worked on in class today. The process that we were using through tracking units is called dimensional analysis, and it's a tool that we'll use throughout the school year in terms of our math problems that we do in class. So what exactly is dimensional analysis? It's defined as the process of changing from one unit to another via the use of conversion factors. So just like we saw with our metric conversions, we could go between those prefixes using the King Henry died by drinking chocolate milk method. If we knew how far apart our prefixes were, we could use that power of 10 to convert from one unit to another. And that is simply dimensional analysis. So the problems that we're going to work on are going to be a little bit more of going from the metric system to the English system. And so in order to do that, we have to use something called the conversion factor. And what a conversion factor is it's a ratio of equivalent measurements. So if you look in the green box in the lower right-hand corner, you'll see one example of a conversion factor. So in order for us to go between the English system of inches and the metric system of centimeters, we can use the conversion factor that 2.54 centimeters equals 1 inch. So if we know how many inches we have or we know how many centimeters we have, we can convert between those two systems of measurement using that conversion factor. And you're going to use it in the form of a fraction like you see here. And how you know what part of the conversion factor goes on top of your fraction and what part goes on the bottom of your fraction is all about tracking your units, which is what this dimensional analysis idea is all about. So you can see some other examples of conversion factors we'll use quite a bit in class, especially the 1,000 base units to 1 kilo of something. So in 1 kilogram, there's 1,000 grams. And we'll also refer to this 1 dozen equals 12 idea a little bit in the next chapter. So let's go ahead and try a few examples. You'll see these on your note packet. So the first example we're going to do together is this one up here. How many feet are in 6.3 centimeters? So what we want to do is we want to figure out where are we starting and where are we going. So in the problem, it tells us we're starting with 6.3 centimeters, and we want to know how many feet that is. So that's kind of our end game. That's where we're going. So to set up the math, we want to go ahead and identify the problem. So we want to know how many feet are equal to 6.3 centimeters. So that's going to be our starting off point. And in dimensional analysis, what you do is you just use a bunch of those conversion factors to get you to the desired unit. So your first conversion factor is going to be 6.3 centimeters on top, and because there's no secondary unit, we assume that the number 1 is below it, but you don't have to write that number 1 down. Now what we're going to do is we're going to use this conversion factor that's provided to us to help us go from centimeters to feet. So I know that 1 inch equals 2.54 centimeters. So how do I know what part goes on top and what part goes on the bottom? When you're doing dimensional analysis, your units always cancel from the top part to the bottom part. So if I have centimeters on the top of my first fraction, in order for my units to cancel, the centimeters must go down here. So if I look at this conversion factor, the 2.54 centimeters goes on the bottom of this first part here, and the 1 inch goes on top of that second conversion factor. And what that does is it allows us to cancel units, because your units will always cancel from the top to the bottom. So now that got me into inches, but I want to get to feet. So I'm not there yet. As a student, I know that in 1 foot, there are 12 inches. And that's just something that we've learned our whole lives in class. So we can go ahead and use this conversion factor to do our last step. So since inches are on the top here, I have to put my 12 inches on the bottom to cancel. And then the 1 foot would go on top. I cancel my units from top to bottom, and you can see that I'm left with feet as my unit, which is what the problem was asking me to get to. So I am done with my math. So what these fractions tell us, the multiply sign in the middle tells us we're multiplying these things. And what you do is you take all the numbers on top and multiply them and get a number. Take all the numbers on the bottom and multiply them and get a number. And then you do that last final math. So 6.3 times 1 times 1 gets me to the number 6.3. 2.54 times 12, when you punch it into your calculator, gets you a number of 30.48. So we need to go ahead and we need to get that to a number. So we're going to do 6.3 divided by 30.48, and that gets us to 0.20669, and then we look back at our last conversion factor to figure out what our unit is. But we did learn our sig fig math rules yesterday, so we do have to take that into consideration. We need to know how many sig figs are going to be in our answer. If you remember from our sig fig rules day, anything that's a conversion factor has an unlimited number of sig figs. So the first number that you're given in the problem is going to dictate how many sig figs your answer will have. Because we're using multiplication, we look at the lowest number of sig figs for our answer. So since 6.3 started with 2 sig figs, our answer is going to have 2 sig figs. So this 0 is our second sig fig. We look behind to round, and it tells us that it's going to round up. So our answer is actually going to be 0.21 feet. And we're going to go ahead and circle that so I know that's the answer. And that's dimensional analysis. It's just simply tracking units from one problem to the next in order to get the desired unit that you want on your number. Let's do one more together, and I'm going to ask you to do this one and put your answer in the Google form, because that's what we'll start with class tomorrow. So the next one we're going to do are how many inches are in 10 kilometers. So again, we want to identify where we're starting. So we're starting with 12 kilometers in our problem, and we want to get to how many inches that is. So we're going to set up the same problem like above. So how many inches are in 12 kilometers? So that's going to be our jumping off point. Now we can use the same conversion factor from up here to go between centimeters and inches, but I'm not in centimeters to start this time, I'm in kilometers. So this is where we can use King Henry died by drinking chocolate milk. Since King stands for kilo and chocolate stands for centi, if you count on your ladder, those things are 5 apart, which means we're going to use the conversion factor of 10 to the 5th. Now remember, when you're using that ladder, your larger unit always gets the value of 1. And since kilo is at the top of that ladder, that means in 1 kilometer, there's going to be 10 to the 5th centimeters. So I'm out of kilometers, and I'm into centimeters, which means with my next conversion factor, I can use this guy up here. I can use 1 inch equals 2.54 centimeters. Because my centimeters are on the top, my 2.54 centimeters must go on the bottom to cancel. And that leaves me with 1 inch on top. So my centimeters cancel. I'm left with inches, which is the unit that I want, so I can go ahead and I can do the math. So I'm going to do 12 times 10 to the 5th, which gets me to, oh shoot, I put the comma in the wrong place. Sorry about that, guys. So that gets me to 12 with 5 zeros. So 1.2 million. And I'm going to go ahead and divide that by 1 times 2.54, which is just 2.54. So I do my 1.2 million divided by 2.54, and that gets me to this gigantic number here, 72440. Now again, we have to figure out how many sig figs our answer needs. So we look at the first number to start. So if we look at 12, 12 has 2 sig figs, and because this is all multiplication, that means our answer is going to have 2 sig figs as well. So the 7 is my last correct number. I look behind, or my last significant figure, so I look behind it to round. It's going to stay a 7, so my answer is going to be 47, and I replace all these numbers with zeros. So it's 470,000 inches is going to be my unit. So dimensional analysis is just simply tracking units, okay? And tomorrow we're going to do a ton of practice in class, and we're going to also tackle a little bit harder type of dimensional analysis. So what I'd like you guys to do is tackle this question that's in your notes, how many seconds are in the month of October, and enter your answer into the Google form when you're complete. Now to help you get started, the month of October has 31 days. So we want to set it up as how many seconds are in 31 days. So using what you know about days, hours, seconds, and minutes, go ahead and convert from those 31 days to seconds and put your answer in the Google form. Remember, if you have any questions, you can always swing by in the morning and ask, and I hope you guys found this helpful. Talk to you later, guys.